Let's look at making some exponential functions and exponential equations. Part A. Arnold dropped a ball during a bouncing ball activity and recorded its height in the table. Part of his table is shown at the right. What is the rebound ratio for his ball? At what height did he drop it? Write your equation. All right, so we need to figure out what the multiplier is to go from 84.5 to 67.6. If I can't do the multiplier in my head, I can undo multiplying by dividing. 67.6 divided by 84.5, and we get a multiplier of 0.8. Using this multiplier, we can work backwards to finish our equation. Working backwards means we're unmultiplying, or again, dividing. So 84.5 divided by 0.8 would put the previous number at 105.625, and dividing by 0.8 again would put the starting point at 132.03. Now we can write our equation. We know that we're going to have a rule that looks like y equals a times b to the x, where a is the starting point, starts at 132.03, and the multiplier is times 0.8 to the x power. Part B. A major technology company, Expo is growing incredibly fast. The latest prospectus said that so far the numbers of employees, y, can be found by the equation y equals 3 times 4 to the x, where x is the number of years since the company was founded. How many people founded the company? Well, to answer how many people founded the company, we just need that starting number in our equation. 3 people founded the company. How can the growth of this company be described? The growth is the times 4. We would say that the growth is multiplying by 4, or quadruple. Part C. A computer virus is affecting the technology center in a way that each day a certain portion of the virus-free computers is infected. The number of virus-free computers is recorded in the table at the right. How many computers are in the technology center? To answer that question, we just need that starting number. How many did they start with? How many computers in the technology center? 27. What portion of virus-free computers is infected each day? How many computers will remain at the end of the 3rd day? Well, we have to look for the pattern. So in this case, to go from 27 to 18, or from 18 to 12, I feel like it's something with thirds. And if we're not sure, we can just divide them. We can do 18 divided by 27, and we'll get that the multiplier is 2/3, or 0.666. So if we want to continue the pattern to number 3, we would do 12 times 2/3, which is 8. So at the end of day 3, there would be 8 infected computers. Wait, 8 virus-free computers. The last question that we skipped over is, what portion of virus-free computers is infected each day? So this 2/3 represents the uninfected computers, which means to answer the question, we actually have 1/3 that are getting infected each day. Part D. A part of a major scandal was it was discovered that several statements in the prospectus for Expo in Part B were false. If the company actually had 5 founders and doubles in size each year, what equation should have printed in the report? 5 founders just means it starts with 5. Doubles means the rate of change just multiplies by 2. So our equation would look like y equals, start with 5 people, and to double I need to multiply by 2 each year, exponential growth. Really quick recap of what we know. Most exponential equations are of the form y equals a times b to the x. What does a represent? A represents the starting point, how many they start with. What does b represent? B represents the multiplier. What is the rate of change? If the multiplier is larger than 1, so if the b number is greater than 1, That means our situation will be exponential growth. The graph will look like this. If our B multiplier is a decimal or fraction in between 0 and 1, that means that we're going to have a situation with decay, where it starts with a lot and it's getting less and less each time. So again, the A is the starting amount, the B is the multiplier rate, and you could find those by looking at your table. You can find the A in the table by looking where the table has a 0 and how much does it start with. And then you can find the multiplier rate if you compare two values in the table and divide them. Let's look at a situation with a percent of growth. You're going to invest $1,000 in a credit union and get 8% compounded interest. That means it's compounded once a year. Here's a situation in the table. Remember from previous chapters that if something is supposed to increase by 8%, we need to write that as a decimal, which looks like 0.08. You can find that by doing 8% or 8 divided by 100. Then to make sure that it's growing, we have to put a 1 in front, otherwise it would be decay. The 1 accounts for having 100% of the amount you started with plus an extra 8%. So in the table, to get from the 1,000 to the next one, we're multiplying by 1.08. What would be the balance after 4 years? Well, we just multiply again by 1.08. If we wanted to write it as like an equation, we'd have 1,000. Our multiplier is 1.08. And it needs to look like exponential rule, so x as the exponent. For our last problem, we're going to look at a third option for investing money in a money market account, which offers 8% annual interest, but this is compounded quarterly, 4 times a year. So that means that this 8% interest has to be divided into 4 parts. And so you're actually earning 2% interest 4 separate times a year. So what they did is they took the 8%, which is 0.08, and divided by 4 because it's quarterly. That quarterly means 4 payments per year, and that gives you 0.02 or 2% every 4 times a year. If instead the example said it was compounded monthly, we would take our 8%, 0.08, and divide by 12 because there are 12 months in a year. If the interest was compounded daily, we would take our 8%, 0.08, and divide by 365 because there's 365 days in a year. And that new number that you get, that smaller decimal, is the decimal we're going to use in our equation as our growth rate. So if we want to write this as a y equals rule, it would look like y equals, starts with $1,000, but instead of putting 8%, we're going to put the 2%, 0.02, and we need the 1 in front to make it growth. And then it's exponential, so x is our exponent. If we want to find how much money they have in 4 years, we have to change how we think about this equation, because now the x exponent no longer means years. X is now measuring quarters of a year because it was quarterly interest. So if we need to have 4 years and there are 4 quarters per year, we would do 4 times 4, which means we're actually getting 16 payments. So when we do our calculation, we're going to have that y equals 1,000 times 1.02 to the exponent of 16. There are 16 quarters in 4 years. And we could calculate a dollar amount.